Welcome to Study Loop.
Talk about this question. It says that four electrons are located at the corner of a square. So if this is a square and the side length is also given as 10 nanometers, so for the moment, let's represent it by d. So we are given the distance is d, and there are four electrons on each of the corner, and at the center we have an alpha particle. So this is the center. We have an alpha particle with charge 2e, and here we have all the electrons. We need to find the work to move the alpha particle to the midpoint of one of the sides of the square. So let's say the alpha particle is moved to here from A to B. So what is the work done? So work done is going to be the change, the charge times. The work done is going to be its charge times the difference of the potential between the 2 points. Uh, now let's find the potential at all the points. So at VA, the potential is due to all the four electrons, and that's going to be identical. So we just need to find this distance, and this is nothing but the diagonal of the square, which is d root 2. So if d root 2 is the total diagonal, then half of the diagonal will be the distance between the electron, one the electron and the alpha particle. So the potential is going to be minus of ke over ke over r, where r is d root 2 over 2. And this is just, and this should be multiplied with 4 because there are four such electrons. So that's going to be negative 8 ke over d root 2. So that's going to be negative 4 root 2 ke over d. So that's the potential at A. We are going to place the value of k and t at last. Then we have to find a potential at B. So the potential at B is going to be the due to these two electrons, it will be same. So that's going to be 2 times minus ke over r, and r is nothing but half the length of the square, which is d over 2. uh, Plus we have these two electrons with with a different distance as compared to the other. So if this is x and this is d and this is d over 2, so using the Pythagoras theorem, x square is equal to d square plus d square over 4, which means that the value of x is root 5 over 2d. So that's going to be 2 times minus ke over root 5 over 2d. So if you're going to simplify this, that's going to be negative 4ke over d minus 4ke over root 5d. So this is the potential at B. So we need to find the work done. So here's the formula for the work done. So we're going to substitute everything over here. So the work done is going to be 2E times VB, which is minus 4KE over D minus 4KE over root 5D minus VA. So minus and minus will become plus. As we become plus 4 root 2KE over D. So we can take most of the things out. So that's going to be ke over d can be taken out. So we are left with minus 4 over root 5 plus 4 root 2. Uh, so this is going to become 2 times k is 9 times 10 raised to 9, e is 1.6 times 10 raised to minus 19 whole square over the distance d. Distance d is given by 10 nanometers. So nano is going to be 10 times 10 raised to minus 9 meters, and this just remains as it is, which we are going to find from calculator. So that's going to be equal to 9 times 2 is 18 times 10 raised to this is minus 8, 8, 17. This is 1.6 square times 10 raised to minus 38. And over here we have minus 4 over root 3 plus 4 root 2. So let me grab my calculator over here and let's find these values. So that's going to be 1.6 square times 18. So that's 46. So that's 46.08 times 10 raised to 17 minus 38 is going to be minus 21, and this approximation is going to be 4 over root 5 uh, minus 4 root 2 to the minus, and that's going to be negative 0.13. So if we multiply this with 46.08, the final answer which we are getting is 6.08, definitely with a negative sign, times 10 raised to minus 21 joules. So this would be the required work done in shifting the alpha particle from center to the uh, middle point of any one side. Thank you.